Dear students and participants of the Railway Engineering course, I welcome you back in the lectures of Railway Engineering. Today we are going to talk about rail sections. In the previous lecture, we talked about the wagons where we have discussed about the ICF wag coaches and the LHB coaches, and there are differences in the benefits which we have derived on using the LHB coaches. Another aspect which we discussed was the coning of wheels. So, the issues which have been faced by the flat wheel system and the remedial measures which have come up in terms of the coning of wheels, but then the coning of wheels have also created some issues and they have been rectified or remedied on the basis of the tilting of rails, and when the tilting of rails also had some issue, then it has been done or rectified using the aging of sleepers or the use of the bearing plates, canted bearing plates. Now, in today's discussion, we are going to discuss about certain aspects related to rails. The first one is the various functions which the rails provide. Second, what are the requirements associated with the rails? Third, what are the standard sections which are in use on Indian railways for different reasons at different locations for different purposes? Then, how the quality of rails is being classified? What are the recommended rail sections and comparison of the various rail sections. So, let us start with the functions which the rails provide when being used as a part of a track. The very first thing it says is that it provides a continuous and a leveled surface. As we see in the photograph which has been placed on the right hand side, the rails have been placed here. So, this is a rail which is being provided and it is being supported by certain system, the sleepers and ballast at the bottom. Now, these rails, whatever the level has been placed, that level is going to be one aspect. It has to be continuous, same level which is being provided, so that there are no undulations, and when the train moves or the wheel moves of the locomotive at the top of it, the passengers are not feeling any such discontinuity discomforts. These needs to be continuous. If they are not continuous, they are being provided with a gap, then that gap has to be filled by way of a certain mechanism, either the welding has to be done or they needs to be jointed there, so that a continuous system is there for 100 kilometers, 200 kilometers or 1000 kilometers for whatever the track has been laid. Another thing is it provides the lateral guidance to the bogie wheels. We have talked in terms of the coning of wheels. In the case of coning of wheels, the wheel was coming at the top of the rail and it was moving laterally because of the clearance which has been provided. So, on the basis of the some irregular features in the track profile or because of certain forces which are there, so lateral movement will always be there. But if this lateral movement is not being restricted, then what will happen? The derailment of the train will be there. So as to reduce that, we need to have the system here, and that is where the rails are providing that lateral guidance, that up to a certain clearance it allows the movement of the wheel and then it just pushes it back, because as soon as it hits, it will go back as a reaction. It bears the stresses which are being induced due to the loading conditions. Due to the temperatures, the thermal stresses are going to be there, and because of the stopping of the trains or because of the movement or the starting of the trains, there are again certain type of stresses which will get induced in the rail system, and the rail system has to bear all of this without getting any defects, without getting distressed. So, this is also a function which has to be there. We will be talking about these stresses or thermal stresses or braking resistances, etc. In the some other lectures which will be followed. It provides a smooth surface, but with some friction. The smooth surface should not be such that there is no friction between the wheel and the rail. There has to be a friction, and that friction helps in terms of providing certain mechanism of stopping the train also. Now, transfers the load to the formation through sleepers and ballast. As you can see here, the rail is being placed at the top of the sleeper, and then the sleeper is having ballast at the bottom, and then ballast is being rested on the formation. So, all of the loads which are coming from the top are slowly getting distributed to a wider mechanism. So, whatever load comes here will first of all come to this one. So, there are different loads being distributed on the sleeper, and this sleeper is having at the bottom the ballast cushion like this. So, it means now finally it is getting distributed to a much wider area, and that is where the formation level will be there. So, this formation level will have sufficient bearing capacity to take up these distributed loads which are coming there. Now, let us talk about the requirements of a rail section. Very first thing is the rail sections are being manufactured using the steel, therefore, the composition of the steel has to be proper. Now, I am not talking here about what are the various types of constituents which are there in terms of minerals, but that is one thing which needs to be taken care of by the manufacturers and has to be ascertained by the engineers when they are going to use that rail as a part of a track. Another thing is the section has to be economical. Now, when you say section has to be economical, one way could have been that we have provided a rail like this as a block. But then what type of stresses are going to be there at different positions or different locations, based on that the designs are made. So, there are different type of designs. One of the design has been shown on the right hand side, which is a flat footed rail, where what you found is it has a base, it has a web and it has a head. So, three parts are there, and all of these three parts are having different amount of metal. But then when you are talking about these metal, we cannot compromise in terms of the three aspects, that is strength, durability and stiffness. So, strength means the load which is coming at the top in this way, or there is a possibility of the lateral forces which are going to be at the rail head because of the hitting of the flange at this point. So, the stability has to be there, the stability is coming from here, the lateral stability is coming by way of the design of the web, and at the same time the wears and tears and the lateral forces and the vertical forces, they have been taken care of by way of the amount of metal which has been placed in the head. And the durability is one aspect which is going to be talked in terms of the reactions with respect to the other chemicals which are coming through the environment, or the possibility of the environmental impacts in terms of the humidity, or in terms of the coastal area which humidity is very high, or in the much green areas where there is a moisture. So, the effect of that moisture and humidity on this rail steel shall be minimal. So, that is another point. It comes from the chemical side, or the metallurgical and the mineralogical side. Another aspect is the CG. The CG of this rail section, at what place it should be. It should be very nearer to the center of the height, and if it happens, then what will be happening is it will be balancing the tensile and the compressive stresses which are going to be induced in this section. So, there are forces which are coming here, so that there will be tensile conditions and the compressive conditions which will be occurring, or that balancing will be there. There is a balanced distribution of material in the head, web and foot of the rail. I just talked about that how the balancing is to be done, and that is again being talked further. But it says in the case of a head, we need to have a adequate depth. So, what is this depth? D. The reason being because there is a continuous wear in this particular area, then even if the wear is there, it should not become non-usable. Up to a certain limit, we can use the rail even if it has got worn out at the surface. So, that is one thing. Another thing is this width which is being provided here. Now, when you are talking about this width, and the wheel is going to be there at the top of this in terms of here. So, this is a wheel. So, this should get an adequate contact area through which the loads are getting transferred to the head. So, this contact area has to be looked at. At the same time, because this wheel is hitting here in this form, there needs to be a adequate lateral stiffness in the head, and all of these things has to be done on the basis of amount of metal which has been provided, what is the height, what is the width, and that has to be decided considering these and doing the test in the laboratory. Another issue is what is the height. Height is from the base to the top. So, this height is another point which needs to be taken care of, and when we are talking about this, what are the aspects we are taking into consideration is this whole of the system is being designed as a beam, and when it is a beam, then we are looking at the stiffness and the strength of that beam with respect to the vertical loads, with respect to the moments which are going to be induced in it because of the hitting by the flanges and the pressure which is going to be there at the bottom. When we talk about the web, then the thickness of the web is important aspect, and this thickness of the web has to be such that whatever the loads are coming at the top in the lateral direction, it should not happen that the head and the web they gets cracked at this particular location. So, the thickness has to be designed in this form. And fractional rigidity of course is the material characteristic, it has to be there because that is where the load taking capacity is going to be decided. When you talk about a foot, it has to be wide enough for stability against overturning. I already talked about it, that if the forces are coming here, it means it is trying to move the rail in this form, and therefore, more of stresses are going to be on this side. Similarly, the other condition may appear depending on which is the running gauge face or which is the outer gauge face. The another thing is that it should be sufficiently thick to withstand the vertical and horizontal forces after allowance for corrosion. So, this is also important aspect. The next thing is that here as you see in the photograph which is being provided on the right hand side, the rails are provided here, and then there is a system which is being used because there are two rails. You can see that this rail is being cut at this point. So, this is rail number 1 and this is rail number 2 which have been jointed together here by using the fish plates. So, we need to talk about that. So, here the fish plate is being provided, this is the length of the fish plate, and there are bolts 1, 2, 3 and 4. There are 4 bolts with the help of which that fish plate is being provided on this side. Now, when we are doing this, what is happening is that this fish plate is going to get connected at this level. So, it is will be something like this. So, this is a fishing angle. Now, this fishing angle has to be designed in such a manner that the fish plate which is being designed gets fit in very easily. So, that there is a proper transmission of load from the rail to the fish plates and then from that to the lower system. And the tightening of plate should not produce excessive stresses on the web on the rail. Now, again there is a level up to which these bolts needs to be tightened, because there is a movement which is going to be there because of the thermal stresses in the rail. So, that is where this joint is being provided. So, the gap is there. So, contraction and expansion will be there. If you have tightened it too much, then this may not be possible. So, there is again a trade off between how much tightening of those bolts needs to be done. Another thing is the section shall be such that it can be economically and efficiently rolled, that is from the manufacturing side, and the fillet radius should be large to reduce the concentration of stresses. Now, this radius which we are talking here, it should be large enough so that the loads which are getting transmitted to the fish plate, it should not happen there is a concentration of the stresses here because of the small area of contact, and in that case what will happen is the wearing and the cracking at the underneath of the head will start taking place, and this is one of the type of the defects which we will be discussing further in one of our lectures. Now, let us talk about the standard rail section. Now, standard rail section, the very first thing is what should be the weight of a rail, and that weight of the rail is being decided on the basis of few variables or considerations. The considerations goes to the heaviest axle load. It also goes to the permissible speed for which we are going to lay that track, what is the depth of the ballast cushion, what are the types and the spacings of the sleepers, and various other factors can also be there. The prime factors are these. So, it means we are talking about a load which is coming from the top, we are talking about the operational side, we are talking about the support side. Now, there is a one thumb rule which says 560 into sectional weight of rail, that gives the maximum axle load the rail can carry. So, how much load that rail can carry is going to be decided by this 560 multiplied by the sectional weight of a rail section, and all of the rail sections which are available, they are defined by their sectional weight. Now, we will be looking at that. So, first of all, let us look at one of the numerical here. What it is being asked is, we have to calculate the maximum axle load which a rail can carry if the sectional weight of a rail is 60 kg per meter or 52 kg per meter or 90 pounds per meter. Now, this 90 pounds per meter, actually this is a rail section which has been taken from the British standards. British were the people who started the railways in India, so they used their own standards in our country, and few of those rail sections are still in use. So, that is where I have taken up this 90 pounds per meter here also as an example. Now, if we go back, so this is the way we can find out 560 into sectional weight of rail, and that is the same thing is being used for all of the three cases. In the first case is a 60 kg per meter, so therefore 560 into 60, that means 33.6 tons, because it was kg, so it is 33600 kgs will be the value, and I have converted into tons. So, it is 33.6 tons is the load which can be carried by this particular rail. If it is a 52 kg, then it can take up to 29 tons. If it is 90 pounds rail, then first of all we have to convert into kgs. So, we are converting into kgs by using a conversion factor of 2.2 here, and it gives you a value of 22.9 tons. That means, if we are going from 60 to 52 to 52 to 90 pounds per meter rail system, your capacity of handling the load is reducing. So, the number, as soon as you get a higher number, so if there is a number more than 60 kg per meter, that will give you an idea that it can take much more loads as compared to the other rail systems. Now, here are the standard rail sections which are there. This is 73 kg per meter, 68 kg, 60 and 52. Mostly these two sections which are defined as a UIC section and IRS section. UIC section is Union International de Chemin de Fer, this is from France, and IRS section, this is our Indian section, this is Indian Railways Standard section. So, these are the two sections which are mostly in use, but in the case of heavy load conditions, we can go to these other two sections which are also being defined as JU 160 section and 136 RE 14 section respectively. Now, let us have some idea about how these sections looks like. Now, the first one, which is having a higher load, this can have a weight of 73 kg per meter and a sectional area of 93 centimeter square. You can see it is not a sort of a symmetrical section. You found that the lengths here are more as compared to the other side with respect to the center line. So, this section is having a depth of 134 mm. All of the units, all of the dimensions, they are in mm here. And the top, if you see, there is a flat area which is of 21, but after that there are 1, 2 and 3 slopes which have been given towards the side. It is not a smooth transition which is being given, and finally it comes out to be 74.5 mm as a width of the railhead, and if we talk about the depth of it, it comes out to be 53 mm. If you look at the base, then this base is coming as 55 plus 85. So, that is 140 mm is the total width of the base. Now, as compared to this one, if you go to the other, that is our 136 RE 14 one, which is 68 kg per meter section. So, the change comes in terms of that it is more of a symmetrical section now. So, whatever is being provided with respect to the center line is symmetrical, and in this case, if you see, the height has been increased to 185.74, the base is 152.40, the top is 74.61 with the flattening of surface as 35.56 and a smoothening of the sides. When you are coming towards the side, there is a transition in a smoother form by using a radius. A higher radius has been used there, and the web is 17.46 mm. The depth of the head is 49.21 mm. and that is how this is a heavier section which is being provided, and obviously if you use heavier section you can take up more loads, and as we have seen in the numerical tube. Now, if we go to the another section, that is IRS 52 kg versus UIC 60 kg per meter, then what are the differences? Let us look at that. In the case of IRS 52 kg per meter, the depth is 156 mm, whereas if you go to 60 kg per meter, the depth is 172 mm. Now, both these sections again they are symmetrical in nature with respect to the center line. And if you look at the width of the head, the width of the head is 67, whereas it is 74.3 in the case of 60 kg per meter. This is almost somewhere around the higher sections. If you see that in the previous one it was 74.61 or 74.5. And if the depth is being low, then depth comes out to be basically 51 mm, and in the other case also it is 51. So, the depths have been kept same. The thickness of the web, that is 15.5 or 16.5. So, there is a more thickening is being provided in the case of 60 kg per meter. The base is 136 in the case of 52 kg per meter, whereas it is 150 in the case of 60 kg per meter. It means more stability has been provided here. So, there is more material which has been put in the UIC 60 kg per meter section as compared to 52 kg per meter section. Now, this UIC 60 kg per meter section, this has been further changed. There are minor changes, of course. Now this is being defined as 60 even profile. This is more accurately dimensioned profile as compared to the previous one. And the variation in the profile is coming in the rail head top. There is no difference in the dimensions on the rail flange and web, including the fishing angles. The cross sectional area is 76.70 centimeter square. If you look at the previous one, it was 76.86 square centimeter for that. Then mass per meter is 60.21 kg per meter. In the previous one, it was 60.31 kg per meter. In the case of rail head top, the changes are in terms of the dimensions. The flat area, which was 21 mm in the 60 kg per meter, now it is 20.456 mm, and the 52 value which was there here, now that has been changed to 52.053 mm. So, these are small changes, but they are bringing up a more accurate dimensioned rail section. Now, there is another section which is being defined by the strength. Now, the previous sections which we have talked in terms of the conventional rails, that is related to 72 kg per mm square strength, ultimate tensile strength we are talking here. But in this 90 UTS section, which means 90 kg per mm square of a ultimate tensile strength section, that is how it is being defined. In this case, the allowable shear stress is 22.5 kg per mm square, but if you talk about the 72 UTS section, it will be 18 kg per mm square. So, there is an improvement in terms of the shear stresses which can be allowed in these sections. And if we talk about the maximum shear stress which is going to be there because of the box end section, then it is 20 kg per mm square. The hardness number is 270 BHN. BHN is a Brinell hardness number. That is a type of a test which is being conducted, and it comes from the name of the person. So, it is 270 BHN as compared to 220 BHN which was there in the case of a 72 UTS section. So, what you can see is there is an improvement in the strength characteristics of a 90 UTS section as compared to 72 UTS section, and this 90 UTS section shall be used wherever the heavy loads are coming on the track. And if you talk about the service life is 50% higher as compared to 72 UTS section. And as soon as this is higher, what happens is it becomes comparable to the life of the other components like concrete sleepers, elastic fastening, etc. That means the requirement of changing the rail before the sleepers have been changed, that is not there. They can together be replaced, and the overall renewal of the track can be taken up together. So, this reduces the maintenance efforts which otherwise requires to be there. And because of the strength parameters, they are adaptable to high speed tracks or heavy load conditions, and they are going to be lesser of wear and tear on curves as well as on gradients because of the stresses or the resistances which the curves and gradients offer to the movement of the train on these type of rails. Now, rails shall be free of manufacturing defects, and for that there is a USFD test, which is ultrasonic flaw detection test. And if this test is being done and manufacturing is being done and you have received a rail as an engineer, and if it should remain free of what it says is that the rail shall be free of the manufacturing defects for a period of 25% of the service life of the rails. So, if it is a 40 years of a service life, for the initial 10 years there should not be manufacturing defect. So, this is what it says, and this is in terms of the load which it is going to carry, which is gross million tons of the load. This is applicable for all the rail types which are of 90 UTS sections or grade 880 or more than grade 880. So, there are this grade 880 is the grade of a steel which we are using in the manufacturing of the rail. Now, if the defect appears within the test free period, then investigations needs to be conducted to ascertain why these type of defects have appeared. So, that is another thing which is to be taken care of. The first thing is to be ascertained with respect to the manufacturer. Here the service life has been defined in terms of the GMT for the 90 UTS rail sections for different rail sections like 60 kg per meter, 52 kg per meter or 90 R rail section. So, what we found is that we go from top towards top, the service life is increasing in a much larger manner. It is 800 GMT in the case of 60 kg per meter as compared to 375 GMT which will be there for 90 R rail. So, almost you can say more than 2 times, it is 2.5 times of an increase in the service life is going to be there, and that has an impact in terms of the maintenance requirements. Now, let us talk about the quality of rail. The quality of rail is taught in the form of prime quality rails or industrial use rails. These prime quality rails, they are suitable for running tracks at all locations, and they are classified as 2 class A and class B rails based on whatever tolerances are going to be there in their and straightness. Whereas industrial use, which is defined as IU, these rails, they are basically used in the as a part of industrial sidings, but in these particular sidings there is going to be a speed restriction of 50 km per hour. And so, as to identify that which one is a prime quality and which one is an industrial use rail, color coding is usually done. In the case of IU, they are being painted blue at the end face of the flange and at the both sides of the flange for a distance of 500 mm from each end. So, as soon as you found that there is a rail which is being painted as this manner, then that can be identified as IU rail. Another thing which is being done is that letter IU is stamped on both end faces. Okay, so their stamping is going to be there. Now, there are certain rail sections which are being recommended for use on Indian railways depending on where they have to be used, and that is what is being discussed here. What it says, in the case of a main line or in the case of track renewals, doubling, new lines and gauge conversions, 60 kg per meter rails with minimum 90 UTS section shall be used. If we have the loop lines and their renewals are there, then 60 kg per meter SH or 52 kg per meter SH rails can be used. If they are private and other sidings and where the certain conditions have been defined, say they are talking about sidings taking off from DFC, that is dedicated freight corridor. So, from a dedicated freight corridor, if some siding is coming towards an industrial premises or likewise, or there are feeder routes to the DFC or 25 ton axle load routes are there, in those cases 60 kg per meter is the rail section which should be used. Then for sidings other than the above with a permissible speed of up to 50 km per hour, we can go to 52 kg per meter SH or 52 kg per meter IU. IU is industrial one, SH is a prime quality which will be there. And sidings other than above with the permissible speed more than 50 km per hour, then we have to upgrade the rail section, and instead of 52 it will be 60 kg per meter. Now, another aspect which we can talk is a rail branding and marking. Now, this rail branding and marking, this is done on one side of the web of each rail is spaced at 3 to 4 meter and the height of the letters is 20 mm. Now, if you minutely see on this rail section which is being shown here, there is something being inscribed here, and that is what is a branding, which tells us what is this type of a rail, from where it has come and how it can be used. Now, what it says is a brand mark includes what? It includes the rail section, the grade of the steel, the identification mark of the manufacturer, the month and the last 2 digits of the year of manufacture, and the process of steel making. These are the things which are going to be there in a sequential manner. So, we will look at just an example. So, there is a marking IRS 52 kg 1080 TISCO 21991 and then this takes to O. What does that means? This is a Indian Railway Standard section. The section is 52 kg per meter. It could have been 960 UIC. The grade of the steel is 1080. The other grade could have been 880. There is a name of the company TISCO. It could have been SAIL also. So, in that case it will be written as SAIL. Then the month in which it is being manufactured, the year in which it is being manufactured, and the process of steel making. This process of steel making can be O or it can be E, depending on whether it is a basic oxygen process or electric process respectively. Now, the grades of the steels which are available, now 1080 grade is available as head hardened rail section or the chromium rail section, whereas 880 grade is available as a copper, manganese or nickel chromium and so like section. So, these are all depends on what type of mineral composition has been there in those particular sections. Now, we can now look at quickly on the types of the rail sections which can be used. You can see there is a first one is a dumbbell shape. Dumbbell shape comes from the name dumbbell itself, which we use for exercise. So, the head as well as the foot, they are of the same type. Now, what was the reason of keeping head and foot of the same type was that if the wear has taken place in the head, then it will be just rotated and the foot will become head and head will become foot. So, the same rail can be used continuously. That was the concept in the development of this dumbbell shape. But the problem was, if the wear is higher, then how to fit that particular rail again, and it has been observed that the wear has taken place much earlier, even again in the head, which is having no wear and which is being reversed from foot to head. So, looking at the amount of wear which is going on in the head, what was discussed and decided further to come up with another section which was bull-headed. And bull-headed section means the head which is being created is having more material as compared to the foot. And when you have more material and even if there is a wear, this rail will keep working, but then it created a asymmetry sort of a condition and there were more of a stresses on the foot. The final one which came up was a flat footed rail, and this flat footed rail, as you can see here, is having 136.5 mm of flat base surface, and we have seen that different type of rail sections are there. So, they have different such dimensions, they have a web and an head, and accordingly they are going to be the different dimensions for the width of the head, the depth of the head, the height of the overall rail section, etc. Now, when we talk about this and we want to compare them, there are different factors on which this can be done. One is the strength. It has been observed that the flat footed rails, they have a higher strength. If we talk about the stiffness, the same comes for that also. The laying and relaying, it has been found easier. There is no requirement of the chairs or no requirement of the keys when we are fitting the flat footed rails, only the clamps are required to be used. Then arrangement at the points and crossings again has been found to be more simpler in the case of flat footed rails. Alignment stability, that has improved in the terms of flat footed or bull headed rail. Rigidity has been found very low in the case of double headed rails or dumbbell headed rails. Replacement is faster in the DH rail, whereas maintenance, there is being observed there is a frequent loosening of fittings in the case of flat footed rails. So, the regular maintenance may be required, and it has been observed it is much expensive even in the case of bull headed rails. Inspection is of course required in all, so that is not a point of comparison we should talk, but initial cost, if we look at initial cost, in that sense the flat footed rail is being observed to be more economical as compared to the other two sections which we discussed. And finally, the lateral stability. The lateral stability is higher in the case of flat footed rail because of the higher base which is being provided in this type of a section. With this, we close this discussion. We discussed the functions and requirements of rails. We talked about the standard rail sections, the quality of rails, the rail sections recommended on the Indian Railways, and the comparative assessment of the different rail sections. Thank you, and we will be meeting in the next lecture again.